Alright, welcome to the demo of our Keylogger project. So the Keylogger is hooked up into the Nexus video board. Our Nexus video board programs directly from an SD card. So if I go ahead and remove USB cords, see, I will start with the board powered off. So the board is powered off. I'll go ahead and power it on. Nothing is plugged into either the program or the UART controller at this time. So we get a busy signal, and we will go to ready here shortly. I have one USB plugged into the HID port, which comes directly from the keyboard. We are now ready. So I can type message to the keyboard, and it will be stored in the VRAM. Enter. We have a few keyboard commands that are going to go in there, so I'm going to show that. And this is the demo. Alright, so now those keys have been pressed, it's been logged. I'm going to go ahead and plug into the UART program with mini USB and sending the code to run. We demonstrated on Terra. There we go. We have Keylogger is initiated. So if we export that data, we can look at our menu. So press E to export, and then 1 will print out the first lines of data. So we can see that I hit into the keyboard, I can type a message into the keyboard, and it will be stored in the VRAM. Then I hit backspace, 4 periods, then a return, return, tab, backspace. This is the demo and a bunch of explanation points. So you can see from just a hardware implementation onto the Nexus video board, keyboard is storing the key presses into memory, and you're outporting those when it comes to the VRAM when hooked up to a UART and programmed after the fact. So we have 4 blocks of data that can be read. Each one is 1024 characters or key presses. Once those 4,000 key presses are full, it rolls over and we'll still start rewriting into the first address. So those 4,096, once filled, we'll just continue to overwrite each other from the very beginning. At any point in time, the last 4,096 characters can be read from the keylogger, and that can be plugged in there. We also had tried to implement plugging it directly into a computer using a pass-through capture with some USB. So we had 2 female USB ports. One would come from the keyboard, one would go to a USB extension cable from here to the board, and then this would be plugged into the computer. This did not work due to serial host protocols. The computer will always default as a host, and for our board to work, it also needed to send to be the host. So having 2 hosts and 1 slave device does not work. Therefore, we were unable to achieve that functionality. We were able to achieve the programming via SD card and the logging of keys, saving into data via just hardware implementation via the USB Type A port using the HID connection. The board is decoding that for us. So the USB signal sent by the keyboard is decoded into a PS2 signal, which the hardware reads, and then our implementation picks up on, changes that to an ASCII value, and stores into the VRAM.